Hello everyone, this is the video for our CGAR 2023 short paper, Augmenting Passage Representation with Query Generation for Enhanced Cross-Lingual Dense Retrieval. My name is Shengyao. This is a joint work with Linjun from Microsoft and Guido from the University of Queensland. The research focus of this paper is enhanced passage representations with query generation for information retrieval. One of the most well-known methods in this direction is Doctor Query. Let's do a quick overview of Doctor Query. The basic idea behind Doctor Query is that for each passage in the corpus, a query generation model is used to generate several synthetic user queries. These generated queries are then appended to the original passage, resulting in a new augmented passage. The augmented passages are indexed, and during the query time, the index is utilized to serve the BM25 ranking model for generating the final ranking. This is a very straightforward framework, but it has been proved to be quite effective. The approach proposed in our paper can be considered as a Doctor Query-like method, but it is specifically designed for dense retrievers rather than traditional BM25. Additionally, our method focuses on cross-lingual passage retrieval setting rather than the classic English-only retrieval setting. Similar to Doctor Query, our method also has a query generation model. However, instead of solely generating English queries, our QG model is a cross-lingual QG model. To achieve this, we use a language-specific prompt to prompt the QG model to generate queries in different target languages. We then encode all the generated queries as well as the original passage into the vector space with the target cross-lingual dense retriever encoder. Next, we augment the original passage vector by moving it towards to the generated query vector. For this, we just use a simple weighted sum between original passage vector and the generated query vectors. And we use a hyperparameter alpha to control the contribution from both sides. We then index the augmented passage vector into the vector index. At query time, the user query is also encoded into the vector space, and hopefully the augmented passage vector of a relevant passage will be closer to the user vector. Thus, the cross-lingual dense retriever can rank it at a higher position of the ranking list. To evaluate our method, we use a popular cross-lingual passage retrieval dataset, XQuadTidy. The query of this dataset has 7 topologically diverse languages, and the corpus has 18 million English passages collected from Wikipedia pages. There are 15K relevant query passage pairs in the training data, and we use this portion to train the cross-lingual dense retriever, which is a MBERT model, and cross-lingual query generation model, which is MT5 based model. We use the official 2K evaluation queries to evaluate the effectiveness of our method. We then report the official evaluation metrics, which are recorded at 2K tokens and are recorded at 5K tokens. For this result, we first investigate the impact of hyperparameter alpha. Recall that this parameter is used to control how much you want to augment the original passage towards to the generated query. 0 means no augmentation at all. As we can see, augmenting the generated query is helpful, and the best value of alpha is somewhere between 0.001 and 0.002. However, values that larger than 0.05 might hurt the effectiveness. We then investigate the number of generated queries. For this, we fix the alpha and we change the number of generated queries for each languages. As we can see, more generated queries is always helpful, and this finding is actually also aligned with Doctor Query. To conclude our paper, we introduced the query generation-based method to enhance the passage representation for cross-lingual dense retrieval. Our method is actually model agnostic in the sense that you can apply it to any existing cross-lingual dense retrievers. We have made our code, trained models, and all generated queries publicly available. Thank you for your attention.